Hi there, this is Professor Eckhouse, and I'm going to talk about algebraic operations on polynomials. So we're going to look at defining, evaluating, and simplifying, adding, subtracting, and multiplying, but we are not covering the division portion. If any of this is hard for you, I highly suggest using the videos in our textbook to learn the material. So there's tons of examples there. All right, so what is a polynomial? A polynomial is a combination of terms called monomials, like this one. So mono means one, poly means many. So the prefix poly means many, and mono means one. So this is a monomial. The coefficient is the number in front of the variable, and there's our variable x, and the exponent is the number that's raised up in the right side. So a polynomial with two terms is called a binomial. And a polynomial with three terms is called a trinomial. After that, there's not really any special names. All right, so some important pieces of information here. An expression that is not a polynomial. There are two reasons that an expression that you might see is not considered a polynomial, and that is if, and this is important, is if the variable is in the denominator, or if the variable is under a radical sign. Okay, so if you see a variable on the bottom of a fraction, it is not a polynomial. If it's under a radical sign, not a polynomial. All right, so here's some examples. Is a polynomial and is not on the right. So why not? This one is there's a 1/2 and the x is in just out front. In this one, though, x squared is on the bottom. On the one on the left here, y is on top. In other words, this is the same thing as 1/4 times y. That's what this means right here. The next one, though, is 2 over y instead of y over 2. 2 over y is in the bottom, not a polynomial. The next one, we've got square root of 12, and then a is on the outside, whereas the one on the right over here, square root of a is under the radical, not a polynomial. Okay, so some terms you need to know: degree, leading term, leading coefficient, and constant term. So the degree of a polynomial is the highest power of the variable that occurs. In the polynomial, the highest power of the variable that occurs. The leading term is not the first one, so that's not how we define the leading term. If it's in standard form, it would be the first one, but it's not always in standard form. So the leading term is the term with the highest degree. So what is a degree? The degree is the exponent on the variable. That's a degree. So the degree of this particular monomial is 3. That's the degree of this. Okay? So leading term is the term with the highest degree. It's usually first, but not always. If it's not in standard form, it's not going to be first. So you have to look for the one with the highest degree. The leading coefficient is the coefficient of the leading term. The coefficient of the leading term. The constant term is the number, whatever number is there, with no variable. Has no variable with it. So what if there is no constant? What if there's no constant? What is it? Then it is 0. All right, so there's always a constant, but if it's not showing, it just means it's 0. So pause the video and take a moment and get all of these terms down. Make sure you understand every single one. Don't just write them down, but think about them. All right, so moving on to the first example. Identify the following for each polynomial. So we're supposed to look at the degree, the leading term, and the leading coefficient for each one. So the first thing you want to do is and these are it's kind of hard to figure out which one you're going to do first, but you want to go through here and you want to find the one with the highest exponent on it. And that is this term here. Don't forget the minus out in front because that does count. Okay, so the degree of this is 3, the exponent on the x. The leading term is negative 7x cubed. And the leading coefficient is the coefficient on the leading term, which is negative 7. Okay, so you make sure you need to know all those different terms and how to find them in a polynomial. All right, so pause the video and try to do the next two. All right, so hopefully you tried these. We've got 3t to the 7th is the highest degree term in this polynomial. So these are each called terms, remember. Each one is a term. So the degree of this is 7. The leading term is 3t to the 7th. And the leading coefficient is 3. All right, the next one. What is the leading term? Find the one with the highest degree, and that is the minus 2p squared. So the degree of that is 2. That's the squared. The p squared, that's just the 2. The leading term is minus 2p squared, and the leading coefficient is negative 2. All right. So some polynomials in standard form. So a monomial is on the left, the binomials come next, trinomials, they have 3 terms, and other polynomials have more than 3 terms. So I want you to pause the video and stare at these and see if you can figure out what standard form means. Okay, so hopefully you thought about that for a moment, and you can see that the degree of these is decreasing, and the constant is last, because that has a degree of 0. If you think about it, 1 has x to the 0, right? Because x to the 0 is just equal to 1. So those are decreasing all the way down to 0. So standard form means that terms are listed in decreasing degree. Terms are listed in decreasing degree. Okay, next we're going to evaluate a polynomial. So you have to be careful when you have negatives. This is one of the biggest problems I see on exams and things like that. So make sure you use parentheses. So I'm going to write this 5x cubed. Whatever x is going to go in those parentheses. Minus 3x squared plus 2x minus 3. All right, so now I'm going to go put x equals negative 1 in for every single one. Negative 1, negative 1, negative 1. All right, so the biggest problem I see is people take these two negatives and cancel them out. That does not work. You have to do order of operations. You have to use the exponents on the parentheses first. So I'm going to say 5 times minus 1 cubed is minus 1, negative 1, right? Minus 3 times, so take this one step at a time, square things first. Negative 1 squared is just 1, plus 2 times negative 1 is negative 2, minus 3. Okay, so let's continue on. 5 times negative 1 is negative 5. 3 times 1 is 3. Minus 2, because plus negative 2 is minus 2. And then we've got minus 3. So do this in order, left to right. Negative 5 minus 3 is negative 8. Minus 2 is negative 10. Minus 3 is negative 13. So that is the final answer. All right, so moving on to the next one, try this one, pause the video, and then come back and watch me do it. All right, so I've got negative 3/4 p cubed plus 2p squared minus p. And we're going to plug in p equals negative 4. So I'm going to put negative 4 here, negative 4 here, and negative 4 here. So remember, simplify in the parentheses with the exponents first. So I've got negative 3/4. So do not cancel these out first. That's not what you do first. So make sure you do the parenthesis. All right, so negative 4 cubed is negative 64 plus 2, negative 4 squared is 16. Minus a negative 4 means plus 4. All right, negative 3 times negative 64, sorry, negative 3/4 times negative 64 is 3 times 16, which is 48, and it's positive. Plus 2 times 16 is 32, plus 4. Now, if this is something that's hard for you, using fractions, just use your calculator on that one. All right, so now we're just going to go left to right. There's no negatives, so you can go in any order, really, and you're going to get 84. All right, moving on. Adding and subtracting polynomials. So adding and subtracting, we really just combine like terms, and then we simplify and write in standard form. So those are the steps. Combining like terms just takes some patience. So I'm going to look, these, notice, are in standard form, which definitely makes it easier. So this is to the second, to the first, and then didn't mean to put a 0 there, the second, the first, and then a constant term. So it's easier to find the degrees of things. So look for the highest degree first so you can find matching things. Over here I have squared on the left, and here I have cubed. So I am just going to put the 8 cubed first. So I'm going to use color coding here, 8 cubed. Now what you might want to do is after you have used it, cancel it out. And that way you're sure not to miss anything. All right, the next one is the squared term. So I've got 7 squared and 5 squared. And you can rewrite these if you want to, especially if you have a minus sign right here. I would rewrite these because you've got to distribute the minus. So 7x plus 5x is 12x squared. So now I'm going to cancel those out or just cross them out so that I can see that I got them. All right, the next one is the x term. So I've got 9x and minus 3x. So 9x minus 3x is 6x plus 6x. And I'm going to cross those out because I've taken care of them. And then the last is the constant term. So I've got minus 15 and plus 20. And that's going to give me plus 5. And I've taken care, double check, I got every single thing taken care of. So that's my final answer. All right, go ahead and try the next one. Now this one has a minus, so the first thing you're going to do is distribute the minus. So give it a try and come back. I'll distribute the minus so you can check that you got it right. Okay, so the first term on this side is an x to the 4th. The one on the right does not have an x to the 4th. So I'm going to, you know what, first I actually think I'm going to distribute. So I'm going to rethink this one. 12x to the 4th minus x squared plus 5x plus 3. Now I'm going to distribute this minus 4x cubed. All right, now I'm going to distribute it to, here. So minus 3x, and I get squared, plus 3x squared. All right, so that's the next one. Now the next one is I have to distribute the minus to the 2x. So minus 2x. And next, I'm going to distribute to the 1. So I get minus 1. All right, now I'm going to combine like terms. All right, I don't have another 12x to the 4th, or another x to the 4th, so I'm just going to write the 12x to the 4th. There's nothing for it to add or subtract with. All right, next I'm going to go to cubed. All right, so I'm going to go find a cubed. I don't have one on the left. The only one I have is here. So, and I forgot to cross this one out. I'm going to cross everything out as I go so I don't miss anything. So I've got minus 4x cubed. All right, then I've got minus x squared and plus 3x squared. Those are my like terms, and that gives me plus 2x squared. All right, I'm done with those. So now I'm going to go look for the next one. Next one down is the x term. So I've got plus 5x and minus 2x. That gives me plus 3x. And then lastly, I'm running out of colors. I have a 3 and a minus 1. So I've got plus 3 minus 1, plus 3 minus 1 is 2. All right, and there's my final very colorful answer. And you can also rewrite this again one more time in between my two steps. Right in here, you can rewrite this with the terms side by side if that helps you. All right, so next we're going to look at multiplying polynomials. We're going to use the distributive property to multiply each term of the first polynomial by each term of the second. And then we combine like terms, and then we simplify. Okay, so this first one, we have just a monomial multiplied times each term. So that's what we're going to have to do. So 2x, and I'm going to write the whole thing. I'm going to write the whole thing out so that you can see each step. Okay, so, and I do recommend this. I know it's more writing, but it really will help you to keep from making mistakes. All right, so 2x times the next one is going to be 2x times 3x, and then 2x times the last one. And don't forget the minus. So I've got minus 2x times 4. Or you can say plus 2x times negative 4, whatever makes more sense to you. I like keeping my minus out front. All right, so now we're going to combine these two, and we get 2x cubed. So remember the exponent rules, right? We're going to multiply those two, and we get cubed. Plus, now we're going to multiply the two numbers and get 6. Multiply the two x's, and we get x squared. And then we get minus 2x times 4. That just becomes 8x. Okay, so double check everything, which I'm doing right now. And it looks good. Check signs especially. All right, so what if we had two binomials? So these are two binomials. And FOIL is just an acronym to help us remember so we don't miss anything. First, outer, inner, last. So just think about this. We're going to take the x and multiply it times this one and then times this one. And we're going to take the 3 and we're going to multiply it times this one and times this one. But using FOIL, it puts the two like terms that are most commonly like side by side. So let's rewrite this and say, okay, we're going to do the first. We're going to call this one the first. So that's our F for first. And then we're going to do outside, inside. And those are the two that'll be side by side, and they'll be similar. Outside, inside. And then we're going to do last. And if you do it in that order of FOIL, it just kind of magically gets in the correct order. And you'll have decreasing degree, and it'll be in standard form. But you don't have to do it like that. You can just distribute and then rearrange. All right, so let's use FOIL to find the product of this. And again, if you have a different technique and it works, fine. It's fine. You can do it. All right, so first is going to be, so that's our F first. So F is 3x times 4x. I'm going to write all of this down, okay? And then I'm going to put a plus for each one and then just keep the negative in there when I need it. All right, so then my outer is going to be these two. This is going to be my O, and I've got 3x times 2. And then my inner is going to be negative 7 times 4x. And my last is going to be 4x times 2. Nope. Sorry. The last is going to be negative 7 times 2. All right. So now let's work this out. I get 3x times 4x is 12x squared. Outside is 3x times 2 is 6x. Inside is negative 7 times 4x, negative 28x. And the last one, negative 7 times 2 is minus 14. Okay, so now we're going to combine these two like terms. And this becomes 12x squared. And this is part of the joy of FOIL, is the two like terms end up side by side in the middle. All right, minus 22x minus 14. Okay, so we just multiplied. All right, so multiplying other polynomials, we're going to multiply every term in one polynomial by every term in the other. So just what we just did basically, but not using an acronym. So we're going to have to do this one. So we get 2x times 3x squared. And then we're going to do this one. So plus 2x times x. And then we're going to have to do this one. Plus 2x times 4. And I'm going to give myself a little bit of space. Actually, I think I'm just going to take this. I'm going to move it down because I want to be able to write the next bit. And I'm also going to shrink it down a little bit. It's a little too big. So, okay. So now I'm going to do the other one. So I've got 5 times 3x squared. So plus 5 times 3x squared plus the next one, 5 times x, plus the next one, 5 times 4. All right, now you just simplify everything. So I've got 6x cubed plus 2x squared plus 8x. And then the other part is 15x squared plus 5x plus 20. All right, so let's combine like terms. So we've got 6x cubed. So that's just going to be 6x cubed. There's nothing to combine it with. Plus, next I've got 2x squared and 15x squared. So that is 17x squared. And I'm going to cross those out as I go, just so I don't miss anything. Hopefully you see how this builds on itself because we are now doing what we did up above. We've got 8x plus 5x, so that is 13x, and I've done those. And then I've just got plus 20. It's by itself, so plus 20. All right, and that is now in descending order. We don't have to rearrange it because we did it as we went. All right, last one. This one has some subtraction, so give this one a try on your own. Okay, so here's what we're going to do. Take the first one, multiply it by the first one over here, and we get 3p times 2p squared. All right, then 3p times minus 4p, or negative 4p. And then we've got plus 3p times 1. Right, once again, I made it too close. I don't have room to write my bottom half. So I want to make sure you can see all of these steps very clearly. All right. So next we're going to go minus 2. So there's a couple different ways you can do this. You can say minus on the outside, or I can say plus negative 2. So either one, I'm just going to leave the minus out front and say minus 2 times 2p squared. So a lot of people do it that way. You might just want to see it that way just for a little change. And then we've got minus 2 times, and we've got a negative 4p. And then the last one is the minus 2 times 1. All right, so now we're going to work on this. And we've got 3p times 2p squared is 6p cubed. And then we've got 3p times negative 4p is minus 12p squared plus 3p. All right, minus 2 times 2 is 4p squared. Minus 2 times minus 4 is plus 8p and minus 2. Now we're going to combine like terms, so pause the video if you haven't already combined and try to do that next. All right, so the first cubed term does not have anything to combine with. The next one is p squared, so we've got minus 12p and p squared and minus 4p squared, so that gives me minus 16p squared. Now I'm done with those, so I'm going to cross them out so I don't get confused. And then I've got 3p and 8p, and that is 11p. Done with those, and then I just get minus 2. Now it's in order. In descending order, just like I wanted it to be, and I am done. Although I think I might have made a mistake. Let's see, 11p. Did I make a mistake? 12p minus 3p and 8p. I think I made a mistake with 3p and 1. I did not. I made a mistake in my notes. Okay, that's it. Thank you for watching.